Hello, everybody, and welcome to Mrs. Baker's Chemistry Corner Monster Paper for Module 10. This is question 4. So magnesium is a metal. Name and describe the bonding in magnesium. Well, all metals undergo metallic bonding. And the description of that bonding, you'll notice that it's a 4-mark question. So you're getting 1 mark here. It means you're going to need to get another 3 marks here. And when you get a question on description of bonding, it is always a 3-mark question. So we bullet point it, and you'll notice they've given you three lines in which to write your answer. So the first thing is that there are positive ions are attracted to a next mark C of delocalized electrons by a strong electrostatic force. You may want to put that these are negatively charged, but you're getting a mark for saying positive ions, C of delocalized electrons, and a strong electrostatic force, or the attraction of a strong electrostatic force. So magnesium oxide, or MgO, is formed when magnesium burns in oxygen. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium oxide. The inner shells have been drawn. Give the charges of the ions. So it's telling us that we need to draw the outer shell electrons, and it's also telling us to give the charges on the ions. So the first thing we can do is give the charges. We're going to look at our periodic table. We're going to find out that magnesium is in group 2, and so it's going to give 2 electrons away and form a 2+ ion. We know that oxygen is in group 6, so it's got 6 electrons in its outer shell. It needs to gain an extra 2 to form a 2- ion. So now how do we know what electrons to give it? Well, metals always jump backwards. So they're going to give away those extra electrons, and they're going to try and achieve the same electronic structure as the noble gas that's in the period before it. So magnesium, when we look at our periodic table, is in period 3. So when it gives away 2 electrons, it's going to have the same electronic structure as neon. Well, neon has 2 full outer shells. We know that because it's in period 2. So we know we have to draw 1 extra outer shell. And we know that we're going to fill it up with electrons that already belonged to magnesium. So we're going to choose dots because Cambridge has chosen to give magnesium dots. So we must show that them with the same formation. If we drew them with crosses, we would be implying that the oxide ion had given away electrons to magnesium, and we know that's simply not the case. So now we go across to oxide. Well, non-metals jump forward to achieve the same electronic structure as the noble gas that's in the same period as it, because it gains electrons. So oxide is also in period 2. So it's also going to achieve the same electronic structure as neon. The only difference is that we will show it to have 6 of its own. So 1, 2, 3, 4, 5, 6 that we draw with crosses, because of course Cambridge chose crosses for the oxygen atom. So we're then going to also show through the medium of dots that we know that these 2 electrons here came from the magnesium. So we're getting 3 marks here, 1 mark for both charges correct and 1 mark for both outer shell electrons correct. Write a chemical equation for the reaction that occurs when magnesium burns in oxygen. So you'll notice it says chemical equation. Chemical equation means use symbols. So we know that we've got magnesium, and it's burning in oxygen. We know that oxygen is always diatomic because have no fear of ice cold beer. So we know that hydrogen is diatomic, so is nitrogen, so is fluorine, so is oxygen, so is iodine, so is chlorine and bromine. We must just remember that as we move forward. So magnesium plus oxygen, arrow meaning makes, magnesium oxide. Now you can either work that out that magnesium's in group 2, so it forms a 2+, magnesium oxide is in group 6, so it forms a 2-. minus, so 2 plus and 2 minus is a 1-to-1 ratio to balance each other out. Or the more astute of you will have noticed that magnesium oxide formula was given to you up there. So even if in the exam you had a complete brain fart and didn't know what magnesium oxide was, which of course wouldn't happen to you, you can have a look in the question. The question's been kind and given it to you. So therefore, we just need to balance it now because we've got 2 oxygens over on the left-hand side. So we definitely need 2 oxygens on the right. And then because we've doubled our magnesiums, we need to double our magnesiums over on the left. And then we've got a nice balanced equation. Magnesium oxide also forms when magnesium nitrate is heated strongly. This is an endothermic reaction. Write the chemical equation for this reaction. Well, we know that all nitrates thermally decompose when heated. It's been kind enough to give us the symbol for, or the formula for magnesium nitrate, which is MgNO32. But if it didn't, we would know, because we've remembered our compound ions, that nitrate has a -1 charge and magnesium's in group 2, so it got a 2 plus charge. So we need 2 nitrates to balance out the magnesium. We're not adding it to anything, we're thermally decomposing, so we're just going to put the arrow in. And then we know, because we've remembered, that magnesium, all metal nitrates thermally decompose into a metal oxide, nitrogen dioxide, and oxygen gas. So let's write that out with the metal in place. So we know we're going to make magnesium oxide, we know we're going to make nitrogen dioxide, and we know we're going to make oxygen gas. Now all we need to do is balance it. So over here, we've got 1, 2, 3, 4, 5. And over here, we've got 6 oxygens. Well, that doesn't balance at all. And so the only thing that we can do is go one more of everything over here, which means now we've got 2 magnesiums over here. We need 2 magnesiums over here. We've actually got 2 times 2 nitrogens because we've got 2 lots of them, and then we've got 2 lots of the nitrate ions. So we've got 4 nitrate ions, which means we must put 4 here. Now let's see how that's doing for us in terms of our oxygens. So over here we've got 2 oxygens, 2 times 1. Over here we've got 4 times 2. Well, 4 times 2 is 8, which means that we've got 8, 9, 10, 11, 12. That's fantastic because over here we've got 2 times 3 is 6, and then 6 times 2 is 12. So everything balances up and we've got a balanced equation. What type of reaction is this? Well, we've already said it is thermal decomposition, which means the breaking down, the decomposing of any substance through thermal energy or heat. Name 2 other compounds of magnesium that form magnesium oxide when heated. So you need to know of 2 other lots of substances that undergo thermal decomposition. We need to know about the hydroxides, and they always make a metal oxide and water. And we also need to know about the carbonates. So we don't want an S on the end. So in this case, we're just going to put magnesium and magnesium. But this question would work with any metal. It doesn't matter what metal they were talking about in this case. We would have just done exactly the same process. So that's it for question 4. Hope that was helpful.